duplicate rows, and ever-growing runtimes. The stream offset never advanced because the task only selected without consuming. Welcome! In this tutorial, you'll learn how to build automated, near-real-time data pipelines using Snowflake Streams and Tasks. We'll cover the basics, then dive into a real production incident and how to fix it. A Snowflake stream is a CDC mechanism that tracks changes on a source table. It records every DML change. Think of it as a security camera that captures inserts, updates, and deletes. Streams are append-only and store changes for a configurable retention period, defaulting to 14 days. Here's how to create a stream on a table and query it. The stream shows only new changes since the last consumption. You can also use system$stream get table timestamp to see when the last change was captured. A Snowflake task is a scheduled object that runs a single SQL statement or stored procedure. You can set it to run on a cron expression or a simple interval like every 5 minutes. Tasks run under the ownership of a specific role, controlling access, and you can also chain tasks together in DAGs, where tasks depend on each other. Here's a simple task that inserts new sales into a report table every 5 minutes. Notice we specify a warehouse and the schedule. After creation, you must resume the task to start it. A common trap: creating a task and forgetting to resume it. Tasks start suspended, so without an explicit alter task, resume, like here, where it's missing, the task never runs. The fix is straightforward. Add alter task my task resume right after the create to activate it. The real power comes from combining streams and tasks. Changes from a source table are captured by a stream. A task runs on a schedule, reads from that stream, and performs a DML operation like insert or merge into a target table. This consumes the stream and advances its offset, so only new changes are processed next time. This task uses merge to handle all 3 change types in one atomic operation, scheduled to run every 1 minute. It reads from the stream using the using clause, then applies the correct action based on metadata $action and metadata $isUpdate. That's the recommended pattern for idempotent pipelines. If the stream has multiple changes for the same key, merge becomes non-deterministic because multiple source rows map to the same target. To fix, use a subquery with row number, partitioned by id and ordered by metadata $row ID, keeping only the first row per partition. This deduplicates the source, ensuring a deterministic update. You can chain tasks into a DAG using the after keyword. For instance, a load task runs first, then a transform, then a report. Use conditional when clauses to skip tasks with no new data. But be aware, this chaining means cascading failures are possible if any earlier task fails. Here, load draw task runs on a 5-minute schedule, and transform task executes right after it completes. Both tasks must be resumed. The dependent task will start automatically once the predecessor succeeds. Monitoring is crucial. Use system$stream has data to check if a stream has unprocessed changes. View task history with task history to see task runs and errors. Also check the stream offset timestamp to ensure it's advancing and set up alerts for failures. These 3 queries are your go-to debugging tools. System$stream has data checks for data, task history reviews task runs, and system$stream get table timestamp shows the stream offset timestamp. Here's how it played out. The task selected from the stream inside a transaction, but never performed any DML. Since the stream offset only advances when a DML statement consumes it, the same changes were read every time the task ran. This caused duplicate rows and increased runtime as more data accumulated. We start with a source table, then data flows into a stream. The fix was simple. Change the task to perform a DML operation like insert into target select from stream. This consumes the stream and advances its offset. Now each task run processes only new changes, eliminating duplicates and reducing runtime. The key fix is simply to use insert or merge. This is the same mistake from that incident. Selecting from a stream without a DML statement leaves it unconsumed. The offset never moves, so you see the same rows every run. The fix on the right wraps that select inside and insert into your target table. That DML advances the offset on each execution, correctly consuming the stream. Follow these best practices for robust pipelines. Use merge to handle DML idempotently, set an appropriate schedule on the target table, recreate stale streams and backfill, and use conditional tasks with when to skip execution when the stream has no data. This conditional task runs every 1 minute, but only executes if the stream has data, saving warehouse credits. The when clause check system $stream has data before the merge. Let's review common interview questions. Understanding streams and tasks is key for SnowPro certification and real-world data engineering roles. Let's recap frequently asked questions about streams and tasks. To recap, streams capture changes, tasks run SQL on a schedule, and together they enable automated near real-time pipelines. Always consume streams with DML, use merge for idempotency, and monitor your pipelines regularly. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.